Hello, welcome to ANS Solver. This is the seventh question of the paper. So each day at a certain doctor's surgery, there are 70 appointments, available in the morning and 60 appointments available in the afternoon. Now, all the appointments are filled every day. The probability that any patient misses a particular morning appointment is 0.04, and if he misses an afternoon appointment, it's 0.05, the probability. All missed appointments are independent of each other. Use a suitable approximating distribution to answer the following. Find the probability that on a randomly chosen morning there are at least 3 missed appointments. So the first thing is clear, we use Poisson distribution because they are independent in nature, which is one of the main conditions. Okay, but now we need in a morning and we need at least 3. These are my two important words. But before that, I need my lambda. My lambda is basically given by a formula called as n into p. So in the morning, the doctor has 70 appointments, which has a probability of 0.04. So I can simply do 70 into 0.04. If I do that on the calci, I can simply say my answer of my lambda is 2.8. So I can simply write my Poisson follows 2.8. So now what I think is we should calculate for at least 3. So that basically means probability of at least, I told you, at least always means the more than equal to sign. Okay? So at least 3. Now I know this basically means the probability of 1 minus the probability of x equals to 0 plus the probability of x equals to 1 plus the probability of x equals to 2. Now I know my Poisson distribution formula is e raised to minus lambda into lambda raised to x over x factorial. So what I can simply do is I can write this as 1 minus e raised to minus 2.8 plus e raised to minus 2.8 into 2.8 plus e raised to minus 2.8 into 2.8 raised to 2 over 2 factorial. So now I can basically write this as 1 minus, I can calculate this full thing on the calci. Okay, so it will take a little bit of time, just give me 1 second. Yeah, so basically, so when I do this on the calci, I get 0.46945. So 1 minus that value is simply 0.531, which is basically the final answer of part 1. Now, part 2. Find the probability that on a randomly chosen day, there are a total of 6 missed appointments. Now, a day consists of the morning, and the afternoon. So basically, your lambda will basically be the lambda of the morning plus the lambda of the afternoon, and you can call this the lambda of the day. Now I know the lambda of the morning, which we calculated in part 1, is simply 2.8. Okay, so I can write this as 2.8. Now the lambda of the afternoon is simple. I know in the afternoon there are 60 appointments and the probability of missing them is 0.05. So I can simply do 60 into 0.05, which will basically give me 60 into 0.05, which gives me the value of 3. So I can simply do 2.8 plus 3, which gives me the answer of 5.8. So now I know this is my final lambda. Now I need to calculate the probability that there are exactly 6. So that's equal to, because of the exactly 6 missed appointments. The formula I know is e raised to minus lambda into lambda raised to x over x factorial. So using this formula, I can write this as e raised to minus 5.8 into 5.8 raised to 6 over 6 factorial. Okay, so you can solve this on the calc. E raised to minus 5.8 into 5.8 raised to 6, okay, over 6 factorial. So when I solve this on the calc, I get my answer as 0.160, which is basically the final answer of my question. Got it? Now, the part 3. Find the probability that in a randomly chosen 10-day period, okay, there are more than 50 missed appointments. So now, write days here and write the lambda here. So in a day, we calculated the lambda here to be basically 5.8, correct? So now I can write this as 5.8. Now I need a 10-day period. So I can simply do 10 into 5.8. So when I do 10 into 5.8, I get my answer basically as 58. Now see, do you think we should use Poisson? Like, should we continue using Poisson? No, because you need to know the condition from converting Poisson to normal. Okay, normal means lambda comma lambda, because your lambda is basically the mean and variance both, correct? So the condition, the main condition of converting from Poisson to normal is basically your lambda should be more than 15. And as you can see, my lambda here, which is 58, is much more than 15. Okay, so now I need to calculate this should be more than 50 missed appointments. So I need the probability of x to be more than 50. Got it? So now what I can simply do is I can make a normal distribution curve. I know my distribution can be written as 58, 58, correct? Because it's always mean comma variance. I know 58 lies somewhere here, and I know 50 lies somewhere here before the mean, obviously. Now I need the area or the probability more than 50. That means I need the area here. Okay, so for that I know my formula is basically z equals to the value minus the lambda over lambda, but the root, because I know lambda is the variance. I need the standard deviation. But now see, a very important thing. Whenever we convert from Poisson to normal, an important thing comes into play, which is called as the continuity correction, which acts upon the test value or the value, which is 50. So now I need more than 50. So the continuity correction goes 50 plus 0.5. The continuity correction is always 0.5. If it's less than, then it's minus 0.5. If it's less than 0, if that's less than equal to, then it's plus 0.5. And if it's more than equal to, it's minus 0.5. But here we simply have more than. So I'll do plus 0.5 to get 50.5. So I can simply write this as 50.5 minus 58 over the root of 58, which basically gives me my z value as 50.5 minus 58 over root of 58, which gives me my answer as minus 0.9847. But now we need more than 50, more than the z value. So we do 1 minus the phi of minus 0.9847. Okay, this is what we need. So now what I can simply do is on the calculator, okay, on the calc, what I can simply do is I can first click on mode. When I click on mode, I can click on 3 where stat is written. Now if I click on 3, I can click on AC. And when I click on AC, I can click on shift. When I click on shift, I can click on 1. And when I click on 1, I can click on 5. Okay. Now I'll get options like 1P, 2Q, 3R, and 4T. Okay. 2 and option 2 and 4 are not important. We care about 1, which is P and R. P basically means less than of the Z value, and R basically means more than of the Z value. So if you see here, I need 1 minus phi, which I know phi means less than. So basically we need more than. So what I do is I click on 3. So when I click on 3, I get this as R and a bracket. In the bracket, you simply put the Z value which you got here, which is minus 0.89847. Okay. So when I do that, I get basically my answer as 0.83764. Okay, which basically gives my final answer as 0.838, which is basically the final answer of my question. Okay.